Good morning, students. You are welcome back to mathematics class. My name remains Ilesomitokwe Joseph. I'll be taking you through trigonometry. In our last class, we discussed about trigonometry, how to find angles using measurement by drawing on your graph and measuring the hypotenuse side, the adjacent side, to get the sine and the cosine of an angles. Now, where we stopped in the last class was the exercises that was given. So I want to do the correction, and to those that do not understand the way I explain the example, please give ears to me. I believe your writing materials are there with you, your textbook, your jotter, your pen and everything, and don't be distracted in any form. Don't ever be distracted. Now, we want to find by drawing and measurement, as in example 1, that is the example that was given in the last class. Sine 20 degree, cos 20 degree, sine 40, cos 40, sine 65, cos 65. Now, in our last class, I told you that the first thing that you do is use a radius. Use a radius of 10 units, that is 10 centimeter. Then draw a quadrant. This is what I'm expecting you to draw. This is a straight line. You draw a straight line on your graph. Then you draw this. Then you draw a circle to cut both the x and the y axis. And you label this one x, and you label this side y. Now, using 1 centimeter to represent 1 unit, that means 5 O's on your graph to represent a unit. And you start from 10, 9, the highest should be 10, then to 0, then this is 10 also. Okay? Having done this, now which angle do we want to do? Sine 20, that is angle 20 degrees. Now, in our last class, you can do it on a particular graph. But if you don't want to run into error, maybe mistake, you can do it separately, just as this. This is, we can do all of these angles on the graph, but we can also separate it on a separate graphs. Now, what is the concept? In the last example that we did, I think I explained angle 25, and 48 also is applicable. So you can do it, just follow the way I want to explain this. Then you can repeat it for that last class and some other subsequent angles that you want to find. Now, pick your protractor. Your protractor, make the line, the 90-degree line, make it to a line on this line. And also let the line also, to align also as this. Your protractor is something of this. Okay, this is 90. So make the line to align, and this is the other part. So place this side on this and measure angle 20. So once you measure angle 20, you just dot it. Then you draw a straight line to that part. Let's say this is angle 20. Now, I can label it O, anything. Okay, I can label this one A. So that means I'm having triangle OA. Now, this is not part of what you did. Now, you now draw a straight line. You draw a straight line. That straight line, so the straight line must start from this part. That is where that line touches that circle end. That is when you now join together. You draw it like this, and it will cut OX. So you can label this one maybe M. Do you see now? So we have OA, which is the hypotenuse side, then AM, which is the opposite side, then OM, which is the adjacent side. Don't forget this is at right angle. It's at right angle. That is 90 degrees. Now, it's very simple. This is what we now measure. Sine 20 degree will be nothing but what? Now, using sine, sokatua, that is opposite over, this side is your opposite, AM, over what? Hypotenuse, which is OA. Use 10 centimeters, or 10 units rather. Okay, so your OA will be 10. Then your your AM. So you use your ruler to measure from ear to ear. What would that give you? From ear to ear, you measure it. Then that would be, okay. Okay. From ear to ear should give you 3.4. Then OA is always 10. So that means my sine 20 is 0.34. That is the value. Then I'm looking for cos 20. Now, to get cos 20, you know, your cos 20 is adjacent over, this is your adjacent. OM is your adjacent. That is adjacent OM over hypotenuse OA. And which will give you, you will use your ruler to measure O to M. And that should give you, O to M should give you 9.4. 9.4, then over 10. And when you do this, cos 20 will be 0.94. So that is that. Now, the second question is on 40, cos 40. So the same thing also applies. Draw, then a quadrant, you label this X, you label this Y, then you label this. To differentiate it, well, I will still use O also as well. So just use a protractor, measure angle, is it 40 now? Okay, measure angle 40, measure angle 40. So let's say it's like this. This is 40. Oh, it's not 400 though. Okay, this is 40. Then draw a straight line. Make this one B. Then draw a straight line. Call this A. So that means sine 40 degree will be opposite BA or AB over OB. And what is your BA? You measure. Measure. Okay, that should give us 6.4 over 10, and which is 0.64. So cos 40 degrees will be adjacent OA over hypotenuse OB. So that should give us 7.6 divided by 10, which is 0.76. Then the last is 65. Cos 65. You draw the same thing also. Call this X, Y. Label it. Don't forget you are using 1 centimeter to represent 1 unit. So that will be 9. This will be 10 to 0, which is O, 0. This is 0.0. Then this is to 10 also. Do you understand now? So you just measure 65. let's say this one is 65. Then you draw a straight line to join it here. Let's call this W, and let's call this Z. Okay, now sine 65 degrees will be opposite. You know, this is at right angle, don't forget. So that will be opposite WZ over OW. So your OW will be 10, because that is the radius that you use. So it can be more than 10. So it will be 10. So your WZ will be, that will be 9 over 10, which is 0.9. And your cos 65 now will be adjacent, that will be OZ over OW. And your OZ means you measure from here to here using your ruler on your this thing. So OZ, that will be 4.2 over 10, which is 0.42. Okay, that's that on the correction to the exercises that was given. Now, in this class, the same lesson objectives as the first class. Divine cosine, we've done that in our first class. Use measurement to find angles, and then I think this is what we'll be talking about mostly in this class. Now, finding angles by drawing. Finding angles by drawing. So what does this mean? Finding angles by drawing. So instead of using tables or calculators, drawing can be used to find the angles of any what? Triangles. Maybe right angle triangle or acute triangle. Okay. Now, find by drawing the angle whose sine is 0.56. Don't forget the ones that we talked about in the first class was by measurement. Find the angles. Okay, sorry. By measurement, find the values of the angles. That is, use measurement to find the sine and cosine of an acute angles. We know that acute angles is angle less than what? 90 degrees. Okay, but greater than 45, but less than 90 degrees. Okay, that was what we did. Now, if you are now given the value, how do you find the angle? If you are given the value, how do you find the angle? The ones that we did is we are given the angle, we have the value using measurement. Also, we can find the angle when we are given the value of that angle, okay, without using calculator or table. Now, what do we have here? The angle whose sine is 0.56. The angle whose cosine is 0.60. Okay? Now, how do we start? The first thing is write 0.56 as a fraction. And when you do that, 0.56 is the same thing as 5.6 over 10. 5.6 over 10. Now, what does this mean? I will just explain this in a nutshell. 5.6 over 10. If you are talking about the cosine, the sine, that means we know that sine of an angle is opposite over hypotenuse, and the cosine is adjacent over hypotenuse. Now, let's follow. It is necessary to construct a right angle triangle with hypotenuse of 10 units and a side of 5.6 units from sine of any angle. Let's say the angle is theta, is opposite over hypotenuse. Do you see now? Now, we've been able to write 0.56 as 5.6 over 10. What does that mean? That means the opposite side is 5.6 and the hypotenuse side is what? 10. Now, draw an arc of a circle center O and radius 10 cm. Draw perpendicular radii OX and OY. I will draw the diagram. Draw a line parallel to OX and 5.6 cm from OX to cut the arc at A. Draw AB perpendicular to OS. The figure below is a scale drawing of the construction. Now, instead of you constructing, just have a sketch like what I have here. You know, it's just like you going back. You know, if we want to get the angle, if we want to get the value as we did in our last class, you know, we draw this, then we draw an arc. This is called an arc. It's also a quadrant, and we know that this is 10 centimeters, and we draw this to be the angle here, and we don't know the angle, but we know that the opposite side, then we draw a line to cut this. Are you seeing it? Maybe I'll draw it very well on a, okay, let me draw it very well. Let me draw it very well on a better this thing. So this is the diagram. Now, you know, we always have this, and we draw an arc. This is called an arc. It's also a quadrant. Then we label this one Y, X. We know that this is the angle. The angle is here like this, and this is maybe let's say angle theta. This is theta. Okay, then we draw a line like this to bisect this. Then we'll call this one to be at right angle. Then let's say this is A, this is B, and this is O. So what this means is that the opposite side, which is AB, this side, is what? 5.6 centimeters. And the longest side, which is the hypotenuse side, is 10 centimeters. So that is the meaning of the that statement. So we've been able to interpret it on a scale drawing as this. So now, what do we now do? We are now looking for the angle. We are now looking for the angle. How do we look for the angle? How do we look for the angle? That is where the question lies now. Now, this is how we look for the angle. Listen very well, carefully. Draw. Okay. Once I explain this, it will also automatically applicable to the next example. Now, how do you measure the angle? Firstly, draw this. Then, you know, it's an arc like this, right? Okay. Now, draw a straight line. Okay. Draw a straight line. Let me say, yes. Draw a straight line. Draw a straight line from here, then measure 5.6. Measure 5.6. Measure 5.6. I mean, you will draw a straight line from here to be 5.6. Draw a straight line from here to here to be 5.6. Let's say this is 5.6. Okay, this is a straight line of 5.6. Now, draw another line again from here to here and measure 10 centimeters. From here to here and measure 10 centimeters. Let's say it is like this. Okay. Now, pick your protractor and now measure this angle. You measure this angle here. Theta. So you are going to get approximate angle of 34 degrees. Now let me recap. Let me explain again. Firstly, draw your line. Draw your line. Then draw an arc like this. Then on this part, you know we said that the opposite side is 5.6. So measure 5.6 from here to here. Let it touch this edge of the circle here. It must touch the boundary, the circumference here. Right? So you measure 5.6. Then from here to here you measure 10. Then you now measure the angle within. Don't forget this will be 90. So that is how to do that. So it also applies to the other parts. You have 0.6, which is the same thing as 6 over 10. And the 6 over 10 means, from your cos, I'm using cos, let me say cos B now. Cos B is adjacent over hypotenuse. So that means your adjacent side is 6 and your hypotenuse side is what? Is 10. So the same thing, draw this line like this, then draw an arc like this. Are you seeing it? Now, you have your adjacent side to be 6. So this is your adjacent side. So measure from here to here, 6 centimeters. Let's say it's on this point, 6 centimeters. Then draw a line to go up here. Draw a line to go up here. Okay. From here to here must be 6 centimeters. From here to here must be 6 centimeters. Then from here to here, you measure 10 centimeters. Then you now measure this angle here, which I call angle B. Do you understand what I just explained now? This is what I explained. Just as we did. Okay? You measure from this is 0, right? From here to here, measure 6 centimeters. Let's say your 6 centimeters is here. So this is 6, 0 to 6. Okay? Now you now draw a straight line. Don't measure this side. Just draw a straight line so that it will touch this edge here of this circle here. Then you now measure from here to be 10 centimeters. Then you now measure the angle using your protractor. That's all. So you're going to get 53 degrees. Now, in the example, a radius of 10 units has been chosen to simplify calculations. So, in everything that you'll be doing, just pick 10 units, which is 10 centimeters as your radius. And it makes your calculation to be so easy and so simplify. Okay? That is good. Now, let's go to what we have next. Use of sine and cosine. Sines and cosines of angles are used to find the length of unknown side in triangles. The table below shows the sines and cosines of some chosen angles. Now, let me draw this diagram. This is a right angle triangle. Then this is angle, maybe angle theta. I'll be using theta. So here will be opposite side, hypotenuse side, and the adjacent side. Now, the opposite side is a length. Then hypotenuse is a length. Also is a length. Adjacent is a length. So cosine and sine helps us to find the length of any unknown side in a what? In any triangle. Maybe acute or right angle triangle. Now, I used calculator to find the sine of all these angles. So complete the table for me. What is sine 40? What is cos 40? What is sine what? Okay, I think sine 40 should be, let me see, sine 40, let me just fill one for you. 0.64. This is for 0.6428. This, because we are taking it to 4 significant figures. That means 4 numbers. Okay. Then cos 40, because of our time, I will not waste time on that. That will be 0.7660. Okay. Then sine 45 and cos 45, they are the same. 0.7071. 0.7071. So just fill in the rest for me. Now, the values in the table are given in 4 significant figures. 4 significant figures. That one is not a problem. Now, we want to look at the example. We know that sine and cosine is used to calculate the length of the unknown side of any triangle, maybe acute or right angle triangle. Now let's look at this example. We want to calculate the value of x in the figure below. Where is the figure? Let me draw it out. We have a right angle triangle. This is angle 90. The angle here is angle 55 degrees, is in degrees. Then the length here is 20 centimeters. And we are looking for x. This is the diagram. So we have the hypotenuse side to be 20, the angle to be 55, and the opposite side is what we are looking for. Okay? In the figure, the hypotenuse side is given and x is opposite the given angle, yes. Anywhere the angle is facing is the opposite side. Okay? Now, how do we solve this? What do we use? Since we have the hypotenuse and we have the angle, but we are looking for the opposite side. So it's just sine theta equals opposite over hypotenuse. So what is your theta? Your theta is 55 degrees. Your opposite side is x, and your hypotenuse side is what? 20 centimeters. So you just cross multiply. That means x equals, so you just press sine 55 on your calculator and you multiply it by 20. Sine 55 multiplied by 20. And I have here 16.383. 16.383 centimeters. Now you can be asked to put this in one decimal place. In one decimal place, that is 16.4 centimeters. This is in one decimal place. Okay, so we can have in two significant figures, that will be 16 centimeters. If it is two significant figures, that means two figures. If it is three decimal places, that will be 16.383. That is after the decimal point, you have three numbers. So since we've gotten x to be 16.383 centimeters. Now find this side for me. Do that on your own. What will you use? Is it cosine that you still use? Is it sine? What will you use? Or is it Pythagoras theorem? What will you use? So this is the exercises that I have for you. We have to find the value of y in the figure. Okay, let me draw it. This is the figure. It's also a right angle triangle. We have this angle to be 50 degrees. We have 17 centimeters, and we have y. So then we have another question here again. Let me use this. This is 30 degree. Then this is at right angle. This is x, and this is 10 centimeters. Okay, this is your exercises. Solve them and get back to me. For your further readings, just try to lay hands on all these materials. So thank you very much for listening. Stay blessed and God bless you.